So many things. One of the things that one of the things you have to do here is that you have to remember not to kill a puppy. I know puppies are the scourge of society, but please don't kill them. I'm sorry. It's so hard to say with a straight face. So you gotta FOIL it out. So you got x squared plus 12x plus 36, 3x plus 36 minus x squared. Okay? Whatever. So as you go through that, you'll notice you have variables on both sides of the equation. What I would always try to strive to do is set one side equal to 0. I'm going to move everything to the positive side. So I have to add an x squared, subtract the 3x, and subtract the 36. Moving everything from the right to the left. So by doing that, I get 2x squared. What's that? Plus 9x is 0. Okay? Now, I don't have a trinomial, but I still have a quadratic. What's the first rule of factoring? Greatest common factor. Wow! So, Devin, what you didn't get to see there is that there's another teacher who's downstairs from us, and about 5 or 6 rooms that way. He's a big jerk. You know why? No, he's not. He's a Cardinals fan. And he also walked and flipped me off. I didn't flip you off. I went like this. And I like you. Maybe. He just did. So that was awesome. Anyway. I'm dumb. Can I do it? Uh-huh. Okay. So now, when you factor out your GCF, you have two terms that you set equal to 0. So in this case here, you have a 0 at 0, and the other one will be at negative 9 halves. It's completely, totally, perfectly fine that when you wind up with a quadratic that only has two terms, your A value, your B value, it's okay. It just means C is 0. That literally means that your y-intercept is at 0. If the y-intercept is at 0, it means the x-intercept is at 0. Okay? So don't freak out when you see those types. You see them a lot, and for some odd reason you guys get it in your brains that you can't do it. You'll say not factorable, and I'll say stop thinking like that because it is factorable. Okay? What else? Any others on those? Yes, ma'am. Same deal. Move everything this time to the right. So I'm going to subtract 2x squared, subtract 4x, add the 1. I get 5x squared minus 3x plus 2. What times what's 10 together to get negative 3? GCF it, as in GCF, comma, it, not F it. That was a joke, Devin. Can you not hear me today? Okay, now we can hear you. I turned up the volume. Oh. Wait. Yes, I wrote negative, I wrote positive here. Sorry about that. Now it's going to work. Sorry, I didn't realize I had written that down. You know, Devin, you distracted me. So better yet, what times what's 10 you add together get negative 11, negative 5, or negative 10, negative 1. Sorry about that, guys. One-fifth and 2. Yeah, I was probably saying add 1 as I was writing down subtract 4. And as I said add, I probably just did the add real quick. All right. Let's hold on to this stuff because what I was telling second hour, what I was telling first hour is that I'm going to switch things up a little bit because we'll come back to it later. But I want to get into the word problem bank of things today real quick. We'll have time, and I'll say I'll show you it. What I decided to do is to switch gears and jump to the word problem stuff now, as opposed to doing another section and then going back to it, because it's going to be easier to do it now because we know enough information. If I wait another day, it's just going to prolong a lot of the other stuff. So it'll work out perfectly for us. Also, I'm going to go hang out with Devin tomorrow. So you guys will be watching me with Devin as seeing the screen as in real time. Mrs. Colvin will be in here with the computers to try to make things work. I know she did that last year a few times with Seth, so you've probably seen it, so it won't be a big deal. The only downfall is that I have to leave during flex, so I won't be around during flex tomorrow. So during first hour tomorrow, it's going to be easier for me just to record everything we do during first hour, and I'll just have that one posted for both first and 12th hour tomorrow. Good chance that they're going to have all the same questions that you guys are going to have on a few of these questions from tonight, as well as what we're going to set up and do, just in case something happens, the lesson will still be there. So if the proverbial poop hits the fan during the thing tomorrow, just watch what first hour is, okay? I will only have maybe 2 more examples from what we do today, tomorrow, but then I'm going to be doing a little bit more of a review, all right? So what I want to do, like I was saying, what I want to look at today is I want to spend time talking about some word problem jump. And you guys, when we do word problems a lot of times in here, it's going to be a lot of basis off of each other. So what I did was I made copies of the word stuff that we're going to look at. So that way you guys don't have to have them worry about continually writing everything down. I have nothing but a person that doesn't like trees. I did. Yes, I like trees. I wish I had more trees in my yard, but I don't. Right. As this is coming forward, I want to show you guys how we're going to be able to extract important terms, extract information from given stuff that looks like it's going to be awful, but yet pretty darn simple. Okay. So make sure you got your calculators out, and we'll walk through a few of these. I almost counted. Oh, do we need one more? Here, I thought I counted right. There's spares. Thank you, sir. Welcome. Thank you, kind sir. All right. So we're doing the one that has the thingy about, it's got the upper left-hand corner, got a picture of a race car on it. That's that single page. All right, so, guys, I'm going to get through a few of these here. Engine torque. Engine torque, Y, in foot-pounds. Torque is what makes things rotate. It's rotational force. So forgot about it. For one model of a car is given by the following awesome quadratic equation. -3, blah, blah, blah. Anyway, where X is the speed of the engine in thousands of revolutions per minute, otherwise known as RPMs. If you ever notice inside of a car, you'll see the you have speedometer and the RPM. RPMs go like 2, 3, 4. Those are all in thousands. It's 2,000 revolutions per minute, and so on. Find the engine speed that maximizes torque. What is the maximum torque? So when I'm looking at this information, right away it tells you that Y is your torque value. X is your RPM. Now, talking about it in terms of a quadratic equation, if I look at it, I see that I have an A value that is negative 3.75. If it's a negative 3.75, what's the graph going to look like? It's going to be down like a frown, right? No matter what, it's going to do this. I know that. I don't know where it's going through. I don't know any of those values at all. But there is one bit of information that I know for dead certain because of the formatting that the equation is given to me. That's standard form, isn't it? What's your value of C represent? The y-intercept, very good. I know that somewhere along the lines, the y-intercept is going to be at 38.8. Okay, I know that. Now, if you think about it, as your engine speeds up, that's what the RPM does. It's going, as the vroom vroom goes low. In my mind, as I was saying, it just made no sense. But as vroom vroom goes, you start to move, don't you? And after a while with engines, depending upon displacement, how big an engine is and things like that, what capacities and stuff are. As you get through a specific torque curve, is what this is really called, your maximum workload occurs at a specific RPM. For some cars, it's at a higher RPM than other cars. For trucks, like big trucks or a diesel truck or things like that, your RPM is at a low end where they have a low end grunt to get things moving. That's why you see pickup trucks pulling campers, not Ford Festivas. Do they make those anymore? Or Fiesta. The Festivas were something else. It was a thing back in the day, but Fiestas were even smaller. Or like Toyota Corollas don't pull boats. Well, all right. You could probably, if you had a canoe on a little trailer, you could pull that. But anyway, but that's kind of where, that's neither here nor there. Now, what I want to do is think about what it says. Find the engine speed that maximizes torque. Your maximized engine speed is going to be along your x value, isn't it? Wouldn't that be located at your vertex? Now, in a parabola, which is this is a quadratic, you either have a what's called a maximum, a high point, or minimum, which is a low point. So vertices, depending upon if your A value is positive or A value is negative, they're either going to be up like a cup if it's positive, which means your vertex is a minimum. Down like a frown if it's negative, which means your vertex is a maximum. So take out your calculator. And what I want to do is go to your y equals. I want to go to your y equals, and I want to put in that specific function. Because I'm going to show you guys how we can map these problems without having to really do a lot of math. Because if we understand what is being looked for, what is the question being asked, if it happens to be a word problem style problem that I allow you to use your calculator, it's just press 1, guys. Right. So our function was negative 3.75 x squared plus 23.2 x plus 38.8. The X button's right here next to alpha. Okay? Go ahead and get that in there. And then what button do you think I'm going to press? Graph. I want to see the visual. Now, my guess is that you guys have a graph right now that looks similar to that. Okay? Now, what happens with this? You did. You didn't make it. So you want to change that? You hit second insert. I'm getting it. Now, right now you can't see it, but if you tilt it just right, the pixels up top, you might be able to see the vertex. You might be able to figure out how far you have to change it. What? Come on! All right, there's a button here that says window. Adjust your window. What we want to do is hit the button that says window, and obviously the vertex is higher than what we're seeing right now, which means which value do we have to adjust? The maximum Y value. Very good. So what we do is we just kind of scroll down. What do you take a guess? Put 50 in and see what happens. Hit graph. See if you see it. Remember, tilt forward. No. Change it again. Try 80. See, sometimes what's going to happen here, guys, is that you might have to play around with the windows to kind of get an adjustment of the graph. Does it work at 80? Good. Are you okay with that? What's that? That's fine. It's going to work just the same. Now, by doing this, now we can see exactly where the torque curve peaks, if you will. Now, there's a button on your calculator that's going to become your best friend for figuring this type of stuff out with quadratics. Not trace, but second, calculate. If I hit the button that says second, then calculate, which is the trace button, you will see that you have options. Value, 0, minimum, maximum. What do you think we're looking for? Exactly. So you can do one of two things. You can press the number 4 for maximum, or just scroll down and hit enter. Either one works. I'm all about efficiency. Yes, sir. You haven't gone that far. You have to do a bunch of questions to it. Empty, what's wrong? Hit second. Hit quit, get out of it. Hit quit, second quit. Hit second plus 712. Second plus 722. It's a hard. I'm telling you how to do a hard reset, and then just start over. Okay. All right. So now I'm gonna hit number 4, and right now it's just blinking. If you read on your cursor, it's asking you for a left boundary. What that means is that the calculator is asking you to place a cursor value. Let me slide this in here real quick so you can see. Actually, I can show Devin. What it's asking you to do with this cursor thing is that it's blinking. So what it's going to do is we're going to move our cursor by hitting the right button. You're going to move your cursor so it's closer to the top. So you just hit right arrow a bunch of times. Don't go too fast because sometimes it takes a second for it to get caught up. There's a little bit of lag. It's just close enough. And now, once you're close enough to the peak that you believe that you want to be, hit enter. And now it changed. See how it put up that X dot, that X imaginary line, that dotted line? The line that's not there, but it's there? Now it's asking you for the right boundary, which means you want to be to the right of the curve. I'm past the peak, and I hit enter. Yes. Purple. Hit enter one more time. There's your maximum. It gives you the value of x that generates the maximum value of y. That means your vertex is located then at, my vertex is located at 3.09, comma, 7468. That relates to engine RPM and foot-pounds of torque. Now, RPM is in the thousands, so that means that at 3,093 RPMs of vroom vroom, it's how it goes, vroom vroom. And then that means you are generating 74.68 foot-pounds of torque to make your car or vehicle move. Okay? That's what that means. What value of X, what RPM generates the value of Y? Do you guys know what's approximately 74.5 foot-pounds of torque? You guys all know what a Harley looks like? Not like the big giant bagger ones, but like a smaller one. That's 74. That's about 75 foot-pounds of torque on one of those engines. Okay. Smaller, I'd say about a Corolla is probably right in that same ballpark as well. Smaller. It's a smaller engine. Okay. Diesel trucks. Anybody have parents have a diesel truck? The new. Well, I have just a regular 1500. Mine has 400 horsepower and like 380 foot-pound of torque. It's just a standard motorcycle. Really loud one. The motorcycle that I have has 94 foot-pound, but 100 some odd horsepower. So it's a little bit geared differently than one stuff. So that's what these do. Yes, sir. Because I knew what the X and Y values related to according to the problem. The problem itself talked about, oops, let me go back up here. The problem here said that torque is given to you in Y. My Y value meant that's the torque. The X value was the RPM. So the ordered pair there was RPM, torque. What is the maximum and what's maximum? What is the revolutions per? What's the RPM that gives you the greatest torque? 3.09 thousand, so 3,093 RPM generates 74 points. Because it'll tell you what the relationship is. Okay. Let's go to the next one. We're going right down the line here, guys. The next one says, although the football field appears to be flat, it's actually shaped like a parabola, so rain runs off either side. It has a crown to it. You guys do that, right? Soccer fields, football fields, whatever. Now, this equation is given to you as Y. But what format is that equation given us to? In a vertex form. Exactly, that's what you meant, in a vertex form. So this is given to you in a vertex form, Y equals A, X minus H, quantity squared. Okay. What does H and K stand for? X and Y. Now, that means what is located at H and K? The vertex. So according to this function, where's your vertex? Your vertex is at 80 and 1.5. Okay. Now, according to the problem, it says that X and Y are measured in feet. Which one is going to be the width of the field, the X or the Y's? The X. What's the Y then? The height. What's the maximum height of the field? It's at 1.5, isn't it? It's 1.5 feet. The maximum height of the field is 1.5 feet. Now, also, if this is at 80, that means that the axis of symmetry is at X equals 80, isn't it? Wouldn't the axis of symmetry be located at the X value of the vertex? Remember that from vertex form? So if it takes from one side of the field to get to 80 is halfway, what's on the other side? How long's the field? No math needed in there. Remember, when you think about the different formats of problems that we have standard form, ax squared, bx, and c, intercept form, where you have your zeros, and then we have vertex form, where you're afforded the vertex. Know that the vertex is going to be the maximum or the minimum value dependent upon the a value. This a value here is negative, which means this has to be the maximum because it's going to be down like a frown. Knowing that the field starts at 0, because you start at 0 when you are counting, to get to 80, and 80 more is 160. That's what that means. It's super fast. Non-mathing math. Okay? Go to the next one. Scientists determined that the rate Y in calories per minute at which you use energy while walking can be modeled by, yes, sir. Yes, sir. They're looking at the what goes up must come down. It has endpoints at 0 and 160. The actual length is something different. That is when we talk about arc length. We'll talk about that later. There's a whole other formula, because you're right. It's like doing circumference. It's circumference on the field, but they're talking about what is the horizontal. I think did it say horizontal distance? They're talking about just the field's width. The field's width is the horizontal distance. The actual distance upon the curve is something different. That's when we get to trig. Don't worry about that now. But you're right. Verify. Anyway, so go back to walking. Determined by the rate, calories per minute, while you're walking can be modeled by this crazy looking thing, where x is walking speed. Again, this is set up in your y equals a, x minus h, quantity squared plus k. Is this up like a cup or down like a frown? It's up like a cup, okay? You know it's up like a cup because our a value is positive. Where's your h and k? Where's your vertex? Okay. So I know that my vertex is located at 90.2 for the x, and my y value is at 51.3. Now, graph the function on the given domain. Okay. Well, the given domain means between 50 and 150. I don't know what it is for the x values, but that's 50 and that's 150. What could I do to figure out these values? I just throw them in the calculator. Okay? I just throw it in the calculator if I want to do that. Describe, but now, if I graph it, I just put those ordered pairs in, but you just throw it in the calculator, you get it. Okay? Just by substitution. Now, the other thing is, describe how energy use changes as walking speed increases. So, this is a real tough question to figure out. As you are walking, he works at Blue Man Group. As he's walking, what is this saying happens as he walks faster and faster and faster? What is he using? It is. That's all it means. The faster you walk, the more energy you're using, the more calories you burn. Yes, sir.
But also, like going really slowly also is that say you go like when you're going really slowly, you're going to go if you want to go.
Now remember, you're looking at it. That's why they give you this range. You're not going to walk any slower than this or any faster than that. That's kind of insane. That's right. But you're right. There's a law of diminishing returns, and that does occur. We don't worry about that. Where's your maximum energy use or minimum? Where's your minimum energy use going to be? Right there. Oh, sure. There's Larson, your car's being towed. All right, never mind. What's the when it says minimize? Basically, what's the vertex? My favorite question on here. The jumping rat. Mouse. The jumping, it's not just a regular mouse, it's the woodland jumping mouse. It can hop surprisingly long distances. I am too. A relatively long hop can be modeled by the blah, where x and y are measured in feet. How far can a woodland jumping mouse hop and how high can it hop? Well, Very high. How high? I don't know. But if I look at this, is this written in any format that we know? No, it's not. We don't have like a factored form. So what I want to do then is I'm going to put this right in my calculator. So go to your y equals table, clear out where we're at, and our function was what? Negative 2/9. Do you guys remember the buttons to press for fractions? What was it? Alpha y equals, good. So we hit the alpha y equals fraction bar. Now it's negative 2/9. Fractions with these calculators, just put the negative in the numerator. Don't worry about it. Negative 2/9. Oh, and make sure you use the button that's... Make sure you use the negative button, not the minus button. The negative button is on the bottom next to the decimal. Negative 2/9 x, parentheses, x minus 6. And again, you don't have to distribute. You put it just like that. Okay? Remember, 2 minutes ago, we did a problem. We changed our window. Remember that? So if I graph this, it's probably not going to show up real clean. It's kind of tough to see. So what we want to do is readjust our window. Oh, Shimki, I forgot to ask you, did it work after you reset? There's probably something stupid. Go back to your window and readjust your x max, or sorry, your y maximum to be 10. I don't think the mouse is going to jump more than 10 feet. He's got mad skills then. Mad hops. So basically, this graph shows that the mouse starts at 0 and jumps surprisingly long distances. Well, I'm an idiot. It's going to feel really weird just doing this in front of one kid. My energy level might be low. Well, so we want to figure out what's going to be the maximum there. Second, calculate maximum, option 4. And again, what we're going to do is we're going to adjust our left and right hand boundaries. Orange, because orange, you glad it's not purple? So my maximum came in at 2.9999978 and 2. Is it the same thing?
Yeah.
Yeah. And that's going to happen a lot of times. You're going to cut stuff where it gets really close to, oh, shoot, they're leaving. Hey, I think I already posted which problems to do on the site. If not, I'll have it up there in like 2 minutes. So that means your maximum height is 3 feet. The maximum height is 3 feet. I'm sorry, the maximum height is 2 feet, excuse me. So if he's got a maximum at there goes the mouse. So if it's yeah. Ralph S. Mouse is gone. Too soon? Too soon. So his maximum height was 2 feet. He got to the maximum height at 3 feet, which means how far did the mouse jump? 6 feet. Remember, this is your axis of symmetry. Your axis of symmetry is at 3. If this is 0, this has to be at 6. Because they have to be equidistant from each other. That's the idea of using the axis of symmetry to make this stuff work. Okay? But that's fine. It works. Okay? So what I'm going to have you guys do this evening, I'm going to walk you through one of them. Yes, sir. You guys can play. Sorry. back to the, guys, if you have to get back out, if you're at y equals, to get back to the regular calculator screen, second win. Now, on this stuff, what I did was, ladies and gentlemen, what I did here was instead of trying to have you guys go through 3 or 4 different sections in the book, I just put them all into a sheet, so that way they're all right there. It was easier than trying to post them and do all that other stuff. So I killed a tree. I'm sorry. Now, what we're going to do this evening is I'm going to have you guys start on, it's nice that the pages are numbered. So on page 4, I want you to do problem number 101. Page 5, we'll do 89, 90, 91, so all 3 of those. Page 6 tells you how to do number 77 on page 7. So do 77 and 78. But I think I have 6 of them for you. And then we'll finish everything out tomorrow. Yeah, the other ones we can build into those tomorrow, which are all kind of the same. Okay? Give those, not tonight, no. We'll get through those. Tomorrow I'm going to show you guys how to do some of the cost analysis ones, which we're going to maximize, I would say maximize probably would. Find our maximum selling price for goods. Before we get to that law of diminishing returns, like you were asking about, where if you sell a radio at $100, but for every $5 increase, you sell 2 less radios. So where does that balance point equal out? And that's what we're going to be able to figure out tomorrow. And that really is, once you figure out how to create the function, it's calculator work. Okay? So try those 6 tonight. Tomorrow, like I said, I won't be here during Flex, so I'm sorry. So you got a question, swing by in the morning. And then I will answer questions, things like that, with Devin and you guys tomorrow and show you guys a couple of the old ones. They're really not bad. These do go pretty quick. So I think that I find these to be a lot easier than the linear program. Unless you just mark this one up. Yeah. All right? We're going to get started. A lot of them are pretty quick on calculator, okay? Yes, ma'am.